We're going to talk about vertical and horizontal shifts of graphs. If c is greater than 0, then the graph of y is equal to f of x plus c is obtained by shifting the graph of y is equal to f of x upward a distance of c unit. So if this is my graph, y is equal to f of x, the graph of y is equal to f of x plus c is just simply shifting the same exact graph up c units. Similarly, if I have f of x is right here, the graph of f of x minus c would shift down c units. So this factor here would determine whether the graph shifts up or down. So if you look at the graph of given the equation of each function graphed, the first one looks like a y is equal to absolute value of x, was originally we're supposed to be right here, shifted down 2 units, whereas the graph of y is equal to absolute value of x is shifted up 1 unit for the second case. So over here, the graph of absolute value of f of x was originally right there. It shifted down 2 units, and whereas here the graph from, it's a rough graph, of y is equal to absolute value of x is shifted up 1 unit. So this was absolute value of x. So the equation of this line would be y is equal to absolute value of x. We're moving 2 units down, so it would be minus 2. Whereas this one, we're moving 2 units up, so it would be y is equal to absolute value of x plus 1. Horizontal translation of graph. If c is greater than 0, the graph of y is equal to f x minus c is obtained by shifting the graph y is equal to f of x to the right. So if you look at this graph here, y is equal to f of x, this graph would shift to the right c units when the equation would be y is equal to f x minus c. Similarly, it would shift to the left c units. The graph of f of x would shift to the left, and the equation would be y is equal to f of x plus c. It looks like it's behaved opposite of what appears. If it's minus c here, it moved to the right. If it's plus c, it's moved to the left. But in reality, this number here is how much you're shifting, and this minus is part of the formula. So this is y is equal to f of x minus c, really. So if this number is the shifting factor and this minus is part of the formula, therefore when you see positive here, that means your c is minus, cause this becomes positive and it shifts to the left. Okay, so you can, however you want to remember this, if you have y is equal to f of x, it would shift to the right when the formula becomes y is equal to f of x minus x. You shift to the left when the formula is y is equal to f of x plus x. Let's take a look at these examples. So give the equation of each function in the graphs below. So here we have absolute value of x. The graph of absolute value of x was originally sitting right here, the origin. So this was y is equal to absolute value of x. Looks like we're shifting to the right 4 units. Okay. So remember, when we shift to the right, that would be y is equal to absolute value of x minus 4. Again, this minus is part of the formula. This is the amount that you're shifting. Your c, or the constant that you're shifting to, is plus 4. We're moving 4 units to the right. So the equation would be y is equal to absolute value of x minus 4. Similarly, we're moving from the origin. Here was absolute value of x. We're shifting to the left 2 units. So the equation of this line would be y is equal to absolute value of x. It really is x minus 2, because we're moving 2 units to the left. Therefore, we write this as absolute value of x plus 2. So we're shifting 2 units to the left. We're shifting 4 units to the right. This is shifting 2 units to the left, shifting 4 units to the right. Again, this minus is part of the formula. So it would be absolute value of x minus 2, or absolute value of x plus 2. That would be the formula for that. We can apply both vertical and horizontal shift. Describe how the graph of each fy of 2 would be obtained by translating the graph of y is equal to absolute value of x. Sketch the graphs of y1 and y2 on the same xy plane by hand. So here looks like that we have a graph of absolute value of x is shifted down 6 units, and here is plus 2, so that really is minus 2, so shifted to the left 2 units at the same time. So the first one, we're shifting the graph of y1 is equal to absolute value of x. We're shifting this down 6 units, and then to the left 2 units. So this is how you translate that. As you can see, point 0, 0 would becomes point -2 and -6. The second one, this 8 means you're shifting 8 units up from the origin, and x minus 2, this value is plus 2 here, so you're shifting to the right 2 units from the origin. So from origin, you shift to the right 2 units, 8 units up, so the point 0, 0 will transfer to point 2 and 8. Same exact graph. Determining domain and range of shifted graph. Give the domain and range of each function. Okay, here we have y is equal to x squared, which originally was right at the origin right here. It was y is equal to x squared. Looks like we're shifting this 2 units up right here and 1 unit to the right. So the first one, the original domain was from negative infinity to positive infinity. The domain still would be the same from negative infinity to positive infinity. However, the range changed. Originally was from 0 to infinity. The range moved from 2 to infinity. So the range will shift up here. So the second one, the graph of y is equal to x to the power of 3 if shifted down 2 units. And this is x minus minus 1, so shifted to the left 1 unit. This is my graph. As you can see, the domain and range of the function is still the same. It's going to cover all the x-axis and cover all the y-axis. Still would be from negative infinity to positive infinity. Here, the function y is equal to square root of x, which was originally at the origin. It shifted down 3 units and it shifted to the right 2 units. It's right here now. As you can see, it changes the domain. Domain was originally from 0 to infinity, now it's from 2 to infinity. That would be the new domain. And the range was from 0 to infinity before, now it's from negative 3 to infinity. It shifted down. That's the new range for this function. So let's take a look at some application problems here. The number of monthly active Facebook user, capital F, is in million from 2009 to 2017 is given by f of x is equal to 233x plus 200, where x is the number of years after 2009. Part A, we want to evaluate f of 2 and interpret your result. For part B, you want to use the formula for f of x to write an equation that gives the number of monthly active Facebook user y in million during the actual year x. And for part C, refer to part B and find y when x equal to 2011. We interpret your result. And for part D, use your equation in part B to determine the year when Facebook reaches 1 million monthly active users. Okay, so we have f of x equal to 233x plus 200, where x is the number of the years after 2009. We want to evaluate f of 2. So f of 2, that's all we have to just substitute for each x2. That would be 233 times 2 plus 200. That results into 666. And the value of 2 corresponds to 2 years after 2009. So it would be 2009 plus 2 would be 2011. So the Facebook has 666 million monthly active user in 2011. For part B, we want to use a formula to write an equation that gives the number of monthly active Facebook user Y in millions during actual year X. So because 2009 corresponds to 0, the graph of f of x equal to 233x plus 200 should be shifted 2009 units to the right. So replace x with x minus 2009 in the formula. So y would be equal to f of x minus 2009 when you shift the graph to the right. Remember, we write this as f of minus this value. So that would be equal to, we substitute for each x minus 2009 into our original f of x equation. So we have 233 times, instead of x, I'm going to put x minus 2009 plus 200. So f of x equal to 233x plus 200, where x is the number of years for 2009. So refer to the part B and y when x equal to 2011. So in this case, when x is equal to 2011, y is equal to 233 times 2011 minus 2009 plus 200, which is equal to 666. So in year 2011, there were about 666 million monthly active Facebook users. So for part D, you want to use your equation in part B to determine the year when Facebook reaches 1 billion monthly active users. So we just have to solve the equation here, and we're going to put 1 billion here. That would be 1,000, and here we just simply distribute. Okay, and in this case we can subtract 200 from each side first, and then divide both sides by 233 and basically solve for x. So approximately Facebook reached 1 billion monthly active user during 2012.